Hello everyone. So in this video we are going to discuss about the advanced concept of queues, dequeues and priority queues. Actually these are enhanced version of the queue data structure with some special applications. So if we talk of dequeue, in this case if we go to the definition specifically, that is a double-ended queue. Usually when we have seen the data structure, one way we can do the process of insertion, and on another way we try to implement the process of deletion. The deletion was done through front and insertion was done through rear. But this type of queue gives us the chance to insert and delete data from both the ends. We can do insertion and deletion, but it could be our left side of the queue or right side of the queue. Once it is fixed, then we can have insertion on one end only, or deletion on another end, or both end. But we'll see certain types of dequeues where we put such kind of restrictions. Okay, so till now it's a general architecture where either deletion or insertion from both the ends we can perform. Now if we talk of types of dequeue, see we have two versions of dequeue data structure. The first type is input restricted queue. Input restricted queue means although we have option to insert and delete, but we have restriction on the input. That input is restricted, means only one way we can have insertion, and other way like deletion process we can do from both the sides. For a row we can have left side, right side, or keep one side fixed, either make it front or make it rear. But if we talk of input restricted queues, we can only enter data from one side only, and deletion could be done from both the ends. So there are two possibilities that we can implement. Either we can do the process of insertion through rear, that was the usual notation that we use, but in this case we have flexibility to insert data from the front as well. But whatever you choose, once you have chosen, that would be the only option in case of the input restricted queue. So insertion from rear in this particular case, one of the version of input restricted, and if we are performing insertion from the front side, in that case we cannot insert from the rear, so one side is restricted. That's why we name it as input restricted queue. Similarly, output restricted queue is a queue where we have flexibility to insert data from both the ends, but only one option for deletion. Okay, so we cannot delete from both the ends. So again we can have two versions. Here in this example, insertion is being done from the front end and deletion is also being done from the front end. So output, that means deletion is restricted, insertion could be done from both the sides, so we can use insertion either from front or rear, or alternatively we can have a different version where deletion is being done from the rear end. So there are different types of operation. Some of the operations like insertion from the rear is usual operation, deletion from the front is usual operation, and the unusual operation which we can do in case of dequeue is deletion from rear and insertion from front. These are the two different operations that we can implement in this case. So this was about the types of double-ended queue. Let us move next. What are the operations? Already briefed that two normal operations that we were doing on queues, insertion from rear and deletion from front. In addition to that, we can also delete element from rear and we can also add element from front. Okay, so depending on the type of queue out of these 4 options of operations available, we can perform 3 operations depending on the type of double-ended queue. If we are talking of input restricted deque, then either we can have operation number 1, that is addition of element at rear end, or 3, delete an element at front end, and 4, delete an element at rear end. 1, 3, 4, why? Because it is input restricted. Only one option, either we can insert from rear or we can insert from front. So if we are fixed at rear, we cannot use front. If we fix front, we cannot use rear. So that's why 1, 3, 4 or 2, 3, 4 operation out of these listed operations we can perform in case of double-ended queue. Similarly, if we talk of output restricted deque, in that case either we can apply 1, 2, 3 operations out of these listed, and or 1 to 4 operation depending on which side we have chosen for restricting the output. Okay, so depending on that, out of these 4 only 3 operation we can apply. Now what are the applications of deque? Double-ended queue, we have flexibility to add and remove data from both the ends. So that concept is used in multiprocessor job scheduling algorithm, where there are multiple processors involved on different processes, and if a separate queue is made and that queue is a deque, is maintained for different processes to be executed by the corresponding processors. In that case, if some processor get free, that processor can delete the process or can remove the process from the queue of another processor, kind of scheduling, in order to reduce the burden on the multiprocessor architecture. So this is a kind of CPU scheduling algorithm in multiprocessor environment where this deque could be used. Otherwise, if we are using normal queues, only either we can remove data from the front or insert data from the rear. But if the front side we want to take out the data, we want to input the data, or from the rear end we want to take out the data, that could be performed in case of deque. Another application is effective palindrome checker program. Like palindromes are the data which are, even if they are reversed, they are same. So we can start from both ends by reading out the data and comparing the elements, whatever we are deleting from the deque. Suppose the data is stored in the deque, from one end we delete, from another end we also apply the deletion process. So that way, if the data stored is a palindrome data, we can simply compare the corresponding character. So one of the application of deque could be used here. And for undo and redo operations, like if we are performing some activity in the word processor, sometimes we want to undo the changes. So whatever changes we made earlier, they are stored in the form of deque, and if we want to again, like some process we have done and we want to reapply that, that is called redo operation. So in order to store the status of such undo and redo operation, we make use of deques. So these are some applications of double-ended queues. Now move to the next topic, priority queue. What is priority queue and how it is different from the normal queue? See, there is only one difference. The normal queue can keep adding the data without regard to the order, like whatever order they are being inserted. But in case of priority queue, we have a special numeric value which describes the order in which the data should be deleted or it should be inserted. We need to take care of this priority value at the time of insertion, and if we are taking care of at the time of insertion, either highest priority or lowest priority number would be at the end, and that could be deleted whenever we apply the deque operation. So that we call it as priority. Every element is associated a number which indicates the priority of that element, that on which order this element should be deleted from the queue. So higher priority is given preference over the lower priority. Okay, and if there is same priority, in that case first come first serve order is used to apply the deletion process. Okay, so in this example, let's say some data is there A, B, C up to Z, and the corresponding priorities are given P1, P2, P3. So smaller the value, larger the priority if this is a system used. In that case, anytime if we want to take out the process from the queue, this A value or A process would be taken out first. So because the priority is highest, lower value is assumed to be higher priority in this case. So on the basis of this concept only, we can have types of priority queue. One is called ascending order, where lower valued number given the higher priority, just like this example. And although we insert the data at random, but after that we arrange the data in such a way that the priority is maintained. So highest priority element comes at the front. So in that case, deletion becomes very easy. So the lowest value number being highest priority value comes at the front, and deletion of that element is done first. Similarly, in case of descending order, we have higher valued number given the higher priority. So according to that, the data is arranged and highest priority number comes at the front. We can delete it first attempt, like at the front whatever data is present shows highest priority, so it is deleted first. Based on this concept, we can see this example. Suppose we maintain certain data in the priority queue, and if we assume that this number represents the priority value, and if the number is low, that indicates higher priority. In that case, if we apply a sequence of dequeue operations, those dequeue operation one by one, first of all will extract the lower number because it's the highest priority. So 5, although we can take out 10, but we are taking out 5 because of the priority. So 5 is deleted first, then 10 is deleted, after that 15, 25, 40, 77. So according to the priority order, the elements are being dequeued from this priority queue. Okay. Now if we want to represent such queue, what are the methods that we can use? The very simple data structure that we can use is one-way linked list, in which at place of using only 2 elements which were there in the previous linked list concept, storing info part and address part, along with that we store a number that indicates the priority of the node. Like this, in 33 is the info part, 1 is the priority, so it is at the front of the queue, and then address of the next node, and the next node is also having lower priority compared to this. Okay, 2 higher number assumed to be the lower priority, equal priority according to the order in which they appear, FCFS. So we maintain a list of nodes according to the priority, and deletion is automatically being done for the node with highest priority first. Other way that we can use is to represent priority queue is use multiple queue for each priority value. Suppose there are many values, many numbers, many data with 1 priority, many data with 2 priority. So we can maintain separate queue for every priority number. So let's say Q1 maintains all those elements which are having the priority 1. So it will start from specific front 0 and will end at the rear for this 0th row if we start index from the 0. Next order of priority data would be stored in this Q2, and next order of priority data would be stored in Q3, and so on. So we can maintain separate queues for different priority values. Otherwise, in the next unit we'll see the tree, data structure and heap. This concept we can also use to represent the priority queue. If we talk of the basic idea, max or min heap, it's a kind of tree where the root is always greater or minimum of the 2 children. So that property is maintained for every root in the tree. So that root element is either maximum value or minimum value. So this maximum minimum value we can relate with the highest or lowest priority. That way we can make use of this concept to represent the priority queue. We'll discuss in detail in the upcoming videos about this heap and heapify process. Now, if we talk of the implementation, we'll give in this slide a brief idea of complexity of these operations is being shown. Like if we use linked list data structure to represent the priority queue, we need 3 operations. Whatever data structure we are using, these are the general 3 operations we need to perform on priority queue to find the peak element. That means which element is having the highest priority, be it a lower number or the higher number. Because if we store in the linked list, the highest priority number is at the front of the linked list. So without moving ahead, the address of the element is stored in the front variable, front pointer. We can directly access that peak element. So this takes big of one time, constant amount of time. If we talk of insertion, in case of insertion, we need to find the appropriate place according to the priority value where that element should be stored. So linearly, maybe in worst case, we'll need to search all the elements and then it will take big of n time. If we talk of deletion, in case of linked list, because again deletion has to be done for the highest priority or the peak element, that is again at the front position, we can simply delete the very first element of the list to perform the dequeue operation. That's why it's constant. Similarly, in case of if we use binary heap or binary search tree where max heap or min heap are used, in that case peak element will take constant amount of time because highest priority element is at the top, at the root of the tree. And if we talk of insertion, in that case we need to apply certain heapify process for max heap or min heap, that takes log n times. So every time the problem size is reduced by 2 till we complete the process of heapification. Similarly, for deletion also, if we disturb the tree, we need to heapify. Although these terms are new terms, you will understand these terms in detail when you will study about the tree data structure. So for the time being, you just need to know that what are the complexity if we follow binary heap representation or if we use linked list representation. Okay. So in this video we have discussed about the concept related to the double-ended queues, dequeues, what are the different types of dequeue and what is priority queue, how it is different from the normal queue. The only difference, we have used only a priority number based on which we delete the data or insert the data. We take care of that priority while insertion as well, and how we can represent the priority queue. So I hope you understood the concept. So we'll meet in the next video. Till then, thank you.